Hello everyone. Good evening. Am I audible?
Yes, ma'am.
Yes.
Good evening.
Okay.
Yes, ma'am.
Good
Shall
evening.
we start today's lecture?
Yes, ma'am.
Just see, we will today see everything about stack. Just see the location of stack here. Stack is located here in the classification of data structures. Okay. You see, stack is here. We will see everything about stack. Just recall the hierarchy of stack. Stack, it is a one type of non-primitive data structure and which is of linear list. Okay, what is stack? It is the example of linear list of type non-primitive data structure. Okay, that means stack, it is the one type of non-primitive data structure which falls under linear list. Now we will start with stack. You see, what is a stack? Stack is a linear data structure which follows a particular order in which the operations are performed. Okay, stack, which is a linear data structure and which is following particular order in which operations are going to be performed. That means in stack, we are able to store the data and we are able to perform operations. But those operations on the stack are always performed in a particular order, right? You can be able to insert elements into the stack and you can delete the elements from the stack. Okay, whenever insertion of an element into the stack, whenever you want to insert any element into the stack, it is called as push operation. And if you want to delete an element from the stack, which is called as pop operation. Okay, that means basically on a stack we can perform two operations, push operation and pop operation. Push operation means if we want to insert data into a stack, then it is referred as push operation. And if you want to delete an item from a stack, it is called as pop operation. Okay, and you see the order of operation performance is always LIFO or FILO. Okay, what type of order is followed in stack? That order is either LIFO or FILO. LIFO means last in, first out, and FILO means first in, last out. Okay, we will see what is the meaning of this LIFO and FILO with the help of this diagram of a stack. Okay, for example, this is a stack and we want to insert number of elements into the stack. The very first element we have inserted is element 1, then element 2, then element 3, then element 4, and then element 5. Okay, this is the top of the stack. We have inserted numbers from 1 to 5 into a stack. Okay, and just see what is the order of inserting elements into a stack. That order is always, you see, last in, first out. That means whatever the last element that you have inserted into this stack, that is the first element which will be out or which will be deleted from the stack. Okay, and the meaning of FILO, first in, last out. Whatever the first element you are inserting into the stack, for example here one element, that will be the last element which will be deleted from the stack. That is the meaning of LIFO and FILO. LIFO, last in, first out. The last element which is inserted into the stack, that is the first element which is deleted from the stack. For example, here 5. And the first FILO, first in, last out. First in, last out means the first element you have inserted into a stack, for example, element 1 here, that will be the last element which will be removed from the stack. Okay, stack always follows this LIFO order or FILO order. This is the concept of stack. In real-time example, we can consider stack example is we are arranging rings one over the another. We are arranging coins one over the another. Or there is a particular stack. In that stack, you are inserting boxes one after the another. Okay. For example, you have a particular stack. In that stack, you are inserting boxes one over the another. Then the last box you are inserting into that particular stack is the first element that have to be out from the stack. Okay, and the very first box you have inserted into the stack, that is nothing but the last box that will be the removed from a stack. Okay, this is the some real-time example of stack. Wait a minute. Next thing, representation of stack in memory. How stack can be represented in memory. Okay, you see, whenever you want to save any stack in computer memory, stack can be implemented or saved by two ways: by using arrays, and the second way is by using pointer. Stack can be implemented in memory or saved in memory with the help of two concepts: by using arrays or by using pointers. If you are using an array to store stack in memory, that is called as static implementation of a stack. Okay, and if you are storing or if you are implementing stack with the help of pointer, then it is called as dynamic implementation of a stack. Right, that means in stack implementation there are two types: static implementation and dynamic implementation. What is static implementation of a stack? If you are implementing or creating stack with the help of array, then it is called as static implementation. What is dynamic implementation of the stack? If you are creating and implementing stack with the help of pointer, then it is called as dynamic implementation of a stack. Okay, for example, here you see here these two diagrams. First, it is the first example of the stack, and the second one, it is the second example of the stack. You see the first one, this one is the representation of a stack with the help of array, and the second one, this is the implementation of a stack with the help of pointer. Why? You see here, with the help of array, we have created stack and we are storing elements 2, then 7, then 6, then 4. We are saving the elements into the stack, and such a kind of representation is called as representing or creating stack with the help of array. Okay, and just observe this second diagram. This is the implementation of the stack with the help of pointer. With the help of pointer means what? We have some memory addresses. For example, here we have memory addresses like memory address first one 203, 204, 205, 206, 207, 208. At memory address 203, we have inserted number 2. At location 205 address, we have saved 7, then 6, then 4. Right? That means if we are inserting elements into a stack with the help of its memory addresses, something like this, then it is called as implementation of stack with the help of pointer. Okay, and as I have already told you, see one example of stack here: arranging coins one over the another. This can be considered as the real-time example of the stack. Then second one, inserting rings one over the another. It is also the one example of stack. Why? You see, because if you want to remove this last coin, okay, this last coin will be the very last coin which is removed from this stack, right? And the newest one, that means the topmost coin, is the first coin that you can be removed from this stack. In the same way, the things are here in terms of this ring circle. Okay, this is the example of stack. There are some basic operations on stack. See, what are the basic operations on stack? First of all, stack function itself, then push operation, then pop operation, then pick operation, then isOmpty operation, and size operation. Okay, these are some basic operations which are performed on stack. First operation is stack function. What is this stack function? It is used to create some new empty stack. For creating a new empty stack, we can use this stack function. With the help of the stack function, we can create empty stack. You see here, it does not need any parameters. That means in brackets, we are not passing any value here. Okay, that is for creation of the stack, no parameters, no values are passed, and it returns some empty stack. Okay, just remember that this stack function, this stack operation, it is used to create empty stack, and it is not accepting any value because the parentheses are empty here. Okay, next operation is push operation. As I already told you, what is push operation? It adds a new item to the top of the stack. If you want to insert new item on top of the stack, then push function can be used. And just see here, to that push function, we have passed item one value. That means we are passing the item that you want to insert into the stack. The next operation is pop operation. Pop means it removes the top item from the stack, top element from the stack. Okay, this here for this pop operation, we are not passing any argument here. We are not passing any item here. Why? Because in stack, there is the rule that always the topmost element will be deleted. That's why there is no need to pass which item you want to delete. Always it deletes the topmost element from the stack. The next operation is pick operation. What is pick operation? It returns the top item from the stack. That means if you want to identify which one is the element on top of the stack, at that time pick function can be used, pick operation can be used. Remember that it just shows you which is the top element, but it does not remove that top element. If you want to remove it, you can use pop operation. Okay, that is nothing but the pick. To identify which one is the topmost element in the stack, pick operation can be used. Next operation is the isEmpty operation. IsEmpty, it is just for checking whether the stack is empty or not. Whether stack is empty or not, for that purpose isEmpty operation can be called. Okay, and the last operation is size operation. Size, it just returns what are the total number of items right now are present in a stack. Right now, how many number of elements are there in a stack? To check that, size operation can be used. These are the some number of operations, basic operations, which can be performed on a stack. Next thing, to see the sum number of stack conditions, there are basically two stack conditions. First one is the overflow. Whether, you see, two conditions can be there. Stack is already overflow and stack is underflow. Stack is overflow means what? Suppose the size of the stack is 5. Size of the stack is 5 means it is possible to insert only 5 elements into a stack. Okay, and already it is full, and still you are attempting to insert some element into that stack, then it is called as stack overflow error. Okay, system will show stack overflow error. You see, depending on the implementation, maybe it may be necessary to check if stack is full or not. Okay, we want to check whether the stack is full or not. Stack is already full, and we are attempting to add some new item into that full stack. Okay, at that time system will return overflow error, or this condition is called as overflow condition. Overflow condition means what? Already the stack is full, and still we are attempting to add some new element into the stack. At that time this condition is called as stack overflow condition. Okay, and this stack underflow condition is what? For example, we have created stack, but right now stack is already empty. There is nothing in a stack. Stack is already empty means, you see this important condition, top equals to null. If we are using top equals to null, if top equals to null means there is nothing, no element is there in stack. This is nothing but top equals to null. Okay, and just see, even though the stack is empty and forcefully you want to remove some item from that empty stack, such a condition is called as underflow condition, and system will return underflow error. Okay, these are the two main conditions for a stack: stack overflow condition and stack underflow condition. Stack overflow means already stack is full and still you want to insert some new element into the stack. This is called as overflow condition. And what is underflow condition? Stack is already empty, top is already null, and still you want to delete some element from the stack. Obviously there is nothing in stack, then what to delete? Such a condition is called as underflow condition, and system will return underflow error here. You see how that push operation works. The process of adding one element to the stack is represented by an operation which is called as push operation. We want to insert number of elements into the stack, it is called as push operation. Okay, you see how the push operation performs. Initially we have created empty stack here. Within that empty stack we are performing operation push A. We want to insert element A into the stack. We have inserted element A, now the top is element A. Again we are performing push B operation. Over A element, B element get inserted and top get changed to element B. Again we are performing operation, for example push C. C element get inserted into the stack and top position get changed to C. Okay, and now for this instance, if you are deleting some element, if you are performing pop operation, then this C element get deleted from the stack and top position will get allocated again to the B. Okay, you see this overflow state condition. Overflow state means what? Overflow state means what? If the stack is already full and does not contain enough space to accept some new item into the stack, such a condition is called as overflow state of a stack. Okay, and here we are representing how the push operation get performed on stack. See the algorithm to perform push operation. Push means we want to insert element into the stack. The steps of algorithms are, for example, we are creating a function with name push. We are passing 4 parameters. First parameter is the empty stack with n number of elements. We are specifying what is the top. We are just creating a top pointer which points to the top element in the stack. Then we are passing size, how many number of elements are right now in the stack. And then we are passing item. Item means the value that we want to push into the stack. Okay, you see what are the steps we are going to perform. Step 1 is that we are checking whether the top is equals to n equals to or not. Okay, n means stack is already full. Stack is already full. Okay, you see if the condition is top equals to n, n is the size of the array, size of the stack. If top equals to n, it is nothing but stack is already full. If stack is already full, if this condition is true, then system should print stack is full and we should exit from this algorithm. Okay, that means we are just checking whether the stack is overflow or not. If top equals to none, then obviously stack is overflow and system should return stack is full and system should exit from this algorithm, exit from the program. Okay, and if top is not equals to null, if top is not n, that means there is some space in stack to insert that new item. That's why we want to insert element now. That's why we are changing this top equals to top plus 1. We are incrementing the top by 1 because we are inserting element. Okay, and that item that we want to insert it will be stored at the top position of the stack. Okay, and finally return. This is the algorithm to perform push operation. Push operation means we want to insert one item into a stack. Okay, this is the algorithmic representation of it. Next one, pop operation. What is pop operation? The process of deleting an element from stack is represented by this pop operation. Okay, we want to delete element from the stack, which is called as pop operation. And whenever we are deleting element continuously from a stack, the top position of this stack gets shrinks. Obviously, we are continuously removing the elements, top position gets shrink. Okay, just see how the pop operation get performed. Initially, pop operation get called, C item get removed from the stack. Again, pop operation get called, B item get deleted from the stack. Again, pop operation get performed, A item get deleted from the stack, and the final result will be an empty stack. Okay, this is the step-by-step execution how the pop operation get called 3 number of times and stack will become empty. See the algorithm to perform pop operation. Algorithm pop function. For this pop function, we are passing two values here. First thing is the stack with n number of elements, and second one we are specifying what is the top position currently in the stack. Okay, so see here we are performing pop operation and we are not passing any item. Why we are not passing any item here? Because in pop operation stack will always delete topmost elements. That's why no need to pass item value here. Okay, just see these are the number of steps for performing pop operation. Initially we are checking whether top equals to null or not. You see the meaning of top equals to null. If top is null, it means there is nothing in their stack. That means the stack is underflow. If stack is underflow, if top is equals to null, then system should print stack is empty and we should exit from the program. Okay, that means stack is already empty, then there is nothing to perform pop operation. We should exit. Okay, and if something is there in a stack, at that time the top value from the stack should be captured in item. That item should be removed and top value should be changed to top equals to top minus 1. As we are removing element, that's why we are performing top equals to top minus 1. We are shifting the position of top minus 1 by 1 position. Okay, these are the steps for performing pop operation. Next thing, applications of stack. You see there are number of applications of stack. I have taken some of those applications. First application of the stack is it is used to reverse a number. Okay, if you want to perform reversing of a particular word, if you want to perform reverse of a word, to take the reverse of word of a particular input word, in that case there is an application of stack. You have to use the concept of stack to print reverse word for input word. Okay, the second application of stack is undo mechanism in any text editor. We are using number of text editors, like we are using PowerPoint presentation, we are using Notepad, we are using Microsoft Office Word. In those applications, some undo button is there. Okay, and that undo operation, that undo mechanism works on the principle of stack. That's why undo mechanism is the example of or the application of a stack. Next thing, backtracking. Backtracking is also one application of stack. What is backtracking? This is a process when you need to access the most recent data element in a series of elements. Once you reach a dead end, you must backtrack. Okay, see in simple language what is backtracking. Suppose you are creating particular Word document, you are writing a program and suddenly the power gets off. Okay, now obviously if you haven't saved that document, you haven't done the recent changes, you have done the changes in that document, and you forget to press Control S. You forget to save that changes. Okay, and suddenly the power get off. Okay, after some time when power comes and you are switch on your laptop or computer system, the system shows you that, prompts you that, system prompts you that just try to recover or try to backtrack to your application. Or in Google Chrome, if you are closing the Google Chrome, or it is get disturbed by some dead end and it get closed, and whenever you are reopening it, it is saving it, it tells you restore. Do you want to restore? That restore application is nothing but the backtracking. Okay, and that backtracking is nothing but the application of stack. The next application of stack is in language processing, compiler's syntax check mechanism. Okay, compiler is doing the syntax checking in any programming language. That syntax checking by the compiler, it happens as per the principle of stack. That's why that compiler syntax checking is also the application of the stack. Next one, conversion of decimal number to binary number. In that case also there is an application of stack. Then to solve a Tower of Hanoi problem, there is an application of stack. Right now I'm not explaining what is Tower of Hanoi problem, but this is one type problem in a particular language, like Tower of Hanoi problem. One standard problem is there, Tower of Hanoi. To solve that problem, stack application can be used, stack can be used. Next one, for converting infix expressions into prefix and postfix expressions, that means in data structure itself also there is an application of stack. In quicksort also there is an application of stack. We are using the concept of stack to solve quick sorting. And for performing runtime memory management, there is the application of stack. These are the some number of applications of stack. Okay, just see. Then arithmetic expressions related with stack. See, what is expression? Expression is nothing but the combination of operands and operators. Okay, for example, when I write A plus B, when I'm writing A plus B, A and B, these are the operands and plus is the operator. For example, here examples of some operands are 2, 5, A, B, and examples of operators are plus, minus, into, divided by. Okay, then by using this operand and operator, we can create an expression. Okay, you see, we can create three types of expressions: infix expression, postfix expression, and prefix expression. Okay, if the operator is in between two operands, then it is called as infix expression. If operator is followed by some number of operands, then it is called as postfix expression. And if operator is followed by number of operands, then it is called as prefix expression. In this way, we can form three types of expressions: infix expression, postfix expression, and prefix expressions. And the last concept is stack as an ADT. Okay, already we have seen what is the concept of abstract data type. Now just see, stack is also one type of abstract data type. Why? Because in stack is the combination of number of elements with number of operations. In stack, we are able to save number of elements and we are able to perform operations like whether the stack is empty, we are able to push some element, we can find out what is the top element, we can perform pop operation, we can check whether the stack is full or not, we can check whether the stack is empty or not. These are the some number of operations associated with stack. Okay, and programmer or the user of a stack does not care how these operations, standard operations of stack, get carried out. Okay, that's why we are considering stack as an example of ADT. Okay, because the definition of ADT says that ADT is nothing but the combination of elements with some number of operations, but user or the programmer don't know how exactly those operations get implemented. In the same thing, stack is containing number of elements, in combination with some number of standard operations, but the programmer have no concern with how those operations of stack get implemented. Okay, that's why stack is considered as an abstract data type. These are the different things about abstract data type. Okay, these are the different things related with stack. Shall we stop here? Are you able to hear me? Hello, Chetan, Praful, Sarthak, Shivam.
Hello, ma'am.
Yes, ma'am.
Yes. So see, today we have already seen what are the stack. We have started with the concept of stack. Then we have seen some examples of stack. Then what are the operations of stack? How those operations get performed. Then algorithms related with stack. Then we have seen some number of applications of stack, and finally stack as an editor. Is that clear?
Yes, ma'am.
Yes.
Okay. We will stop here, and tomorrow we will start with the concept of queue. Fine?
Yes, ma'am.
Shall I end the meeting?
Thank you, ma'am.
Okay. Thank you, everyone.
Yes.
Thank you, ma'am.